To wire the primary of a transformer for 220 volts, 50 Hz input, you will need a transformer with a primary rated for 220 volts, 50 Hz, electrical wiring, a voltmeter, and wire strippers. Firstly, ensure the power supply is disconnected before proceeding. Secondly, identify the primary terminals on the transformer. They are typically marked as 1, 2, and N. Next, connect one wire from the ground conductor, usually green or bare, to the metal case of the transformer. Then, connect the other two wires from the power source to the 1 and 2 terminals of the transformer. It does not matter which wire goes to which terminal for a single-phase transformer. After this, using a voltmeter, measure the voltage between terminals 1 and N, or 2 and N, to ensure it is approximately 220 volts. Lastly, tighten all wire connections securely using a screwdriver. The transformer should be rated for the appropriate power consumption of the machine. The transformer should be installed in a well-ventilated area. If the transformer has a nameplate with a connection diagram, follow the instructions carefully. Always refer to the manufacturer's instructions for specific wiring details. To elaborate further on transformer wiring, consider the specific application and load requirements. Firstly, determine the volt-ampere, or VA, rating of the transformer needed to supply the machine. Select a transformer with a VA rating that is equal to or greater than the machine's power consumption to avoid overloading the transformer. Overloading can lead to overheating and premature failure of the transformer. Secondly, verify the insulation class of the transformer. The insulation class indicates the maximum operating temperature of the transformer's windings. Ensure the insulation class is suitable for the ambient temperature in which the transformer will be installed. Higher ambient temperatures require higher insulation classes. Thirdly, check the impedance of the transformer. The impedance affects the voltage regulation and short-circuit current. Lower impedance transformers generally provide better voltage regulation, but result in higher short-circuit currents. Consider the available fault current at the installation location when selecting a transformer impedance. Fourthly, consider the type of transformer. Common types include EI-core toroidal and autotransformers. EI-core transformers are the most common and are suitable for general-purpose applications. Toroidal transformers are more efficient and have lower noise levels but are typically more expensive. Autotransformers are smaller and lighter but do not provide electrical isolation between the primary and secondary windings. The grounding of the transformer case is crucial for safety. The ground connection provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Ensure the ground wire is properly sized and connected to a reliable grounding electrode system. The size of the ground wire should be determined based on the size of the overcurrent protection device protecting the circuit. Refer to the applicable electrical codes and standards for the correct grounding requirements. When connecting the primary wires to the transformer terminals, use appropriately sized wire connectors. Wire connectors should be rated for the voltage and current of the circuit and should be suitable for the type of wire being used. Ensure the wire connectors are properly tightened to provide a secure and reliable connection. Loose connections can cause overheating and arcing, leading to equipment failure and fire hazards. When measuring the voltage between the terminals, use a true RMS voltmeter. True RMS voltmeters provide accurate voltage readings for non-sinusoidal waveforms, which are common in electronic equipment. Standard voltmeters may not provide accurate readings for non-sinusoidal waveforms. After completing the wiring, perform a thorough inspection of all connections. Check for any loose wires, damaged insulation, or other potential hazards. Use a megometer to test the insulation resistance of the transformer windings. The insulation resistance should be above a minimum threshold to ensure the insulation is in good condition. Also, verify the polarity of the transformer windings if the application requires it. Incorrect polarity can cause damage to the equipment being powered by the transformer. When selecting a location for the transformer, consider ventilation, accessibility, and environmental conditions. The transformer should be installed in a well-ventilated area to prevent overheating. Ensure the transformer is easily accessible for maintenance and inspection. Avoid installing the transformer in areas with excessive moisture, dust, or corrosive fumes. Furthermore, document all wiring connections and test results. Keep a record of the transformer specifications, wiring diagram, and test results for future reference. This documentation can be helpful for troubleshooting and maintenance purposes. Always follow the manufacturer's instructions and applicable electrical codes and standards when installing and wiring a transformer. Incorrect wiring can be dangerous and can cause damage to the equipment. If you are not comfortable working with electrical equipment, consult a qualified electrician. Remember to use appropriate personal protective equipment, or PPE, such as safety glasses and gloves, when working with electrical equipment. Energize the circuit before making any connections or performing any maintenance. Lockout and tagout procedures should be followed to prevent accidental energization of the circuit. Regular maintenance of the transformer is essential for ensuring its reliable operation. Inspect the transformer regularly for signs of damage, overheating, or corrosion. Clean the transformer windings and enclosure to remove any dust or debris. Check the tightness of all connections and tighten them if necessary. Perform insulation resistance tests periodically to monitor the condition of the insulation. Replace the transformer if it shows signs of significant degradation or failure. In addition to the above steps, consider the following factors when wiring a transformer. Firstly, the inrush current. Transformers can draw a high inrush current when they are initially energized. This inrush current can be several times the normal operating current and can trip circuit breakers. Use a slow-blow fuse or a circuit breaker with a high instantaneous trip setting to accommodate the inrush current. Secondly, harmonics. Nonlinear loads can generate harmonic currents that can overload the transformer and cause overheating. Use a K-rated transformer or a harmonic filter to mitigate the effects of harmonic currents. Thirdly, voltage taps. Some transformers have voltage taps that allow you to adjust the output voltage. Select the appropriate voltage tap to match the voltage requirements of the equipment being powered. Fourthly, the ambient temperature. The ambient temperature can affect the transformer's capacity. The transformer's capacity is typically rated for higher ambient temperatures. Refer to the manufacturer's specifications for the rating factor. The type of enclosure must be considered. The enclosure protects the transformer from environmental factors such as moisture, dust, and corrosion. Select an enclosure that is appropriate for the environment in which the transformer will be installed. Also, consider surge protection. Surge protection devices, or SPDs, can protect the transformer from voltage surges caused by lightning or switching transients. Install SPD on both the primary and secondary sides of the transformer. Be sure to also think about the transformer's efficiency. Transformer efficiency is the ratio of the output power to the input power. Higher efficiency transformers consume less energy and generate less heat. Select a transformer with a high efficiency rating to minimize energy costs. And furthermore, think about noise levels. Transformers can generate audible noise due to the vibration of the core and windings. Select a transformer with a low noise level if noise is a concern. Always follow the manufacturer's instructions and applicable electrical codes and standards when installing and wiring a transformer. Incorrect wiring can be dangerous and can cause damage to the equipment. If you are not comfortable working with electrical equipment, consult a qualified electrician. Remember to use appropriate personal protective equipment, such as safety glasses and gloves, when working with electrical equipment. Energize the circuit before making any connections or performing any maintenance. Lockout and tagout procedures should be followed to prevent accidental energization of the circuit. Regular maintenance of the transformer is essential for ensuring its reliable operation. Inspect the transformer regularly for signs of damage, overheating, or corrosion. Clean the transformer windings and enclosure to remove any dust or debris. Check the tightness of all connections and tighten them if necessary. Perform insulation resistance tests periodically to monitor the condition of the insulation. Replace the transformer if it shows signs of significant degradation or failure.